Okay, now that we've finished solving practice problem number 30, going through and using the p-value method, now we're going to go through and use the critical value method for solving this same problem. So here if we're looking at our critical value method, again, the first step is finding our test statistic. So we have that the same as we did before, that's given in the problem. So z-score is one standard deviation above 0, tells you that your z equals 1. So we have that. And now our next step is we need to find our critical values. That's the name of the particular method. For finding our critical values, we need to go through a series of steps. So first of all, here we've got our alpha as 0.05 from the problem. We need to know if it is a two-tail or a one-tail test. So looking at this particular problem, is it a one-tail or a two-tail? Is going to be a two-tail. Remember, we're looking here at differences. So we're going to take our alpha level of 0.05 and divide it by 2 to get our probability area. Notice we've got, if we're looking at this again, you can see here on the left with the two-tail that you're going to be taking your alpha of 0.05 and actually splitting it to two different sides. If we kept it at 0.05, what we would wind up when we totaled it up would then be an alpha of 0.10, and that's not what we're solving for. So we take our two-tail, take our alpha divided by 2 equals our probability area. So here it's 0.05 divided by 2 equals 0.025. Okay, now we go through and locate 0.025 in the z-distribution table. And remember again, you're working with the probability, you're looking to find the z critical value. So you're going to be looking at 0.025 in the body of the table. And when you do that, we get 1.96. Okay, but this is a two-tail. So if we're working with our z-distribution, we're going to need to have it on either side. So it's going to be negative 1.96 and 1.96 is going to be our two z critical values. And you notice I've used the labeling here of L and R. So that is my z to the left and my z to the right. So I have a z left and a z right. That helps keep it straight in your mind when you're graphing all of this out. So now we have our critical values. We have a z to the left and we have a z to the right. So next step is graphing it out. So we're literally going to graph, drawing it over just like this. So you can see here we've got our basic distribution, and I've gone through and set this up for how we would solve for any two-tailed critical value method approach. So we've got our ZL on the left and our ZR on the right. At opposite ends, extreme ends of our distribution, and you notice I've got the area to the left of the ZL that's shaded in as our region where we reject the null hypothesis, and then we have the region to the right of the ZR, which is also where we reject the null hypothesis, and the space in the middle is if the is where we would fail to reject the null hypothesis. So once we have this graph in place, our next step is going to go through and add on our actual values. So here we have our ZL is negative 1.96 and our ZR is 1.96. So I've added those on now for my values. And the next step then is plotting in my actual z, my test statistic, which here is equal to 1. So I've plotted that into my graph as well. Now, a moment here looking at how I've labeled these. Notice I've added one other layer to the labels on these. So I've got my z critical value to the left. That's what that CVL stands for. And my z critical value to the right. That's what the CVR stands for. I like to do that just to clarify that they're critical values. And then so you can see my z, and I've labeled it with a lowercase t. That's my personal notes telling myself that it's the test statistic. So you may find that helpful for yourself. If you're getting confused as you're trying to solve these problems and graph them out, you may in fact want to add this extra layer of identification. So our last step here is assessing the rejection. So here we are looking at making an assessment. So looking at our data and where our z-test statistic is falling, would we reject the null or would we fail to reject the null? We would fail to reject the null as it's falling in the fail to reject region. So here we have failed to reject our null hypothesis. And then again, moving on, we're back to the same level of restating the decision in non-technical terms to address the original claim. And this is going to follow just like the same level that we value. So again, there is the language pulling from this wording of the final conclusions and then presenting it back out in basic language. There is that there is not sufficient evidence with this sample to indicate that the X sort increases the chance of having a baby girl. So notice we've solved this problem now both from the p-value approach and from the critical value approach. So the next two tutorials that you have for this section are going to be looking at more practice problems and also going to be looking at using StatsCrunch to be able to solve some of these problems.